Welcome to my video on graphing trig functions. Now actually the title should just say graphing a sine function because that's all I'm looking at here and that's our focus for our course. So our steps, first of all, is you need to understand what the sine function or cosine function looks like and be able to plot that. So I do have that as step number one, but technically you might get to the point where you're leaving out step number one. Since this function that I have here as an example is in terms of sine, I have to know what my sine actually looks like. So I'm going to just do that in black here. I know that sine starts at the has a y-intercept at the origin at 0, 0. It has its maximum of 1 at 90 degrees. It has a spot back on the axis of the curve of 180 degrees. At 270 degrees, it's at its minimum, which is -1, and by 360, it has completed a full entire cycle, and it's back on the axis of the curve. So I'm going to try and draw this, but it's not going to look super awesome. Let me do that again. I didn't do much better this time. Okay, so because my scale is so small, it's kind of hard to make it look like the nice smooth curve that it should. Okay, and then of course that would continue on in both directions, but that's just one cycle of it. Next, I want to use the period to stretch or compress this graph horizontally. So if I look at what I have here, my k value is the 2, which means then the period is going to equal, try this again, period is going to equal 360 degrees divided by that k value, divided by that 2. So the period in this case is going to be 180 degrees. I'm compressing it by a factor of 2. So instead of spanning 360 degrees to complete the cycle, I'm only going to cover 180 degrees to complete an entire cycle. So if I compress this horizontally, my 0, 0 point is anchored there, but then I'm pushing all those points horizontally, those other 4 points horizontally, to be half the distance that they were before. So the period is 180. That means the cycle should end here. Halfway in between, I should be on my axis of the curve. Halfway between the 0 and a 90, I should be at the maximum. Halfway between 90 and 180, at 135, I should be down at the minimum. So I've just taken that sine curve that we have and I've now compressed it by a factor of half as much as what it was before. Okay, so I have now taken care of the period part of it and compressed it horizontally. Now if my k was negative, I could have also done a reflection over the y-axis, but I don't have to worry about that here. Now we're moving on to step number 3, which I'm going to do in green. So this was my step 2 in blue. In green, apply the vertical stretch or compression and reflect over x if needed. So that's this piece right here. Whoops, wrong color. This piece right here. So I want to reflect it. So I'm going to flip it over the x-axis and I'm going to stretch it at the same time. So instead of only being a max of 1, it's going to be a max 3 times as big. It'll be a max of +3. And instead of being a min of -1, it's now going to be a min of -3. So I'm going to do both things at the same time. I'm flipping, so that means I'm going to head down this way, but I'm also going to stretch it, which is going to pull that down to the -3 there. So let me just undo that first line I drew. I want to pull it down to the -3. So this is the reflect piece and the stretch all in one shaboodle. Okay, so then this comes up and comes back down. So now we've got this much of our graph taken care of. So the green graph, what I've drawn here, is just one cycle of y equals -3 sine of 2x. Now my last step, I'm going to move my graph right or left if I need to, and up and down. I'm going to combine that in one step here. So this part says I'm moving to the right 3 units and I'm moving down 1. So I'm going to take this point at the origin, I'm going to move it to the right 30 degrees. Now I've set each square up here to be 15 degrees, so I'm going to go right by 2, and I'm going to move down 1. So that point is now going to land here. I'm going to take my next anchor point, move right 30 degrees and down 1. And so on with all my anchor points here. Right 30, down 1. Right 30, down 1. Right 30, down 1. Okay, so now I've got 5 new points, which I am going to draw my curve through. And there we go. There is one cycle of the graph that I have given you. Now, I can extend this. If I notice my pattern, each of my anchor points, those 5 key points, are 1, 2, 3 blocks away from each other. So right here, I'm on my axis of the curve. 3 horizontally, I should be down at the minimum. Okay, and then 3 horizontally from there, I should be back at my axis of the curve, which is at -1. 3 horizontally from there, I should be at my maximum, which is at +2. And likewise, if I look over here, I can go 3 horizontally to the left, and then I would be up at my maximum. And I could extend it the other way as well. Okay, I could keep going with that if I had more grid to work with. So now we have our final function of y equals -3 sine of 2 bracket x minus 30. I might be running out of room here. X minus 30 bracket -1. And there we have it. Hopefully that helps you with your graphing.